Hey guys, in this particular video, we'll be studying about distributed systems, and this will be the part 2 of system design primer series video. The first video is already out, in which I've told that what system design exactly is and uh, what is the roadmap for this. So this will be the second video, and in this particular video, we'll be talking about what distributed systems are in a nutshell. So quickly traversing that what we are going to study in this. First is what is distributed system, and then second is the characteristics of distributed systems, some of the basic concepts, and what is the motivation to use distributed systems, and what are the types of distributed systems. We'll probably take one example to see. So let's quickly start that what distributed systems exactly is. So you might be aware of, like, whenever we design or whenever we see any application, like, uh, let's suppose YouTube or anything, and it is being made up of different components and different software, different services. Okay, so in a way, distributed system is collection of separate and independent software and hardware components, which are known as nodes in that. And these nodes or components are networked together, and they work together coherently to fulfill one end goal. So for example, YouTube and Google are itself a distributed system. Okay, so how will look like, they have servers to receive users request, either to watch or to upload a video in YouTube. The end goal is obviously that it's a video platform, so you'll be watching videos. So that's the end goal for YouTube. And it has processing queue to process the request, and there will be encoders to encode the videos, and they'll be using databases, metadatabases, video thumbnail storage, etc. So all those components are different and separate, but they are networked together, and they work coherently uh, to serve one purpose. So that's why it is like, it's called distributed. Okay. However, for the client, user or device, these internal complexities are hidden. So let's suppose you are watching a video, but you are not aware of, like, how they are doing encoding of a video. Like, you are watching a video, and if your network connection is slow, it will show you the video in less resolution on 480p, or if your connection is good, it will be showing you in 1080p. So that's like automatic conversion happens based on the network, or even you may select manually also from the platform that is being given. But how does YouTube do that? Those complexities are hidden from the client or user, you may say. So for user, it appears as a single system. Like, it's like all the you are not aware that what is going on behind the scene, you as in user. So but as a developer, now since you are studying system design, and you will be preparing for interviews, so obviously you need all those things to know. And so let's see, like, what is it looks like a distributed system. So here, let's suppose there is a your client, and client request, let's suppose this is the system. This appears as a whole system to you. This drawing I have drawn is not that good, but internal complexity is like, inside this there will be separate components which work together to serve the request of the user and send the response, and it appears as a one system. So this is like view, you can say, in distributed systems. Let's move on further, like, what are the characteristics of distributed systems. So first characteristics is there should be no shared clock. That means, uh, let's suppose you are running your you have one machine, let's suppose your computer itself, and you are running everything onto that, like, uh, in a local host, like even your server which serves APIs, that is also there. your database is also there, everything is in the one system and they are sharing a clock, right. So this will not be called distributed system. So uh, first thing is like they should not have shared clock, but logical clock they will be achieved when they will be synchronized. Like if suppose client and server both running on local computer, will not be considered as distributed, correct? That's what I've explained. And similarly there should be no shared memory also. Like every component which is separated out, its state should be distributed. Nearly each process or component must be independent, must have its independent memory, so they should not be sharing it in one system. Next is like there should be concurrency. What concurrency means is like you have heard about word like multi-threading, doing tasks in parallel. So they should be doing the tasks or process and they should be doing it parallelly. Like it should not be sequentially. So concurrency is one of the thing which distributed systems should have. And the next is loose coupling. What does loose coupling means? uh, so let's suppose you have a couple of services or couple of systems or servers, they can use different operating systems and different technologies. It is not a must, but it's good to have. Like for example, let's suppose even in the microservices you have seen, so we'll be talking about what microservices is in one of the next videos. But even then in the microservices also, like one service is using Java, other can use Golang or Python. Similarly, if your one system is using, let's suppose, Linux server, and one of the system is using Windows server, Windows operating system into it, that's completely fine, and that will depend on the trade-offs you want to make and what all things you need into that. So it is good to have, but it's not must. So let's move on to some basic concepts and terminologies which distributed system should is having, and we should be aware of. So we talked about like components, different components that are called nodes. So here what node is exactly, let's see. Like node can be hardware, it can be piece of software also, and it can be open or closed. So what does open network and closed network means? That like some nodes are bounded together and some are not. So here in the diagram you can see this particular diagram. This is the example of open network, kind of like three are together, but these are not making a closed mesh kind of. But here you can see these nodes are like every node is connected to mostly all other nodes by via some other node. Let's suppose this is A and this is B, this is C and this is D, and let's suppose this is E. So A is connected to C via B and C here, even via A and C also, and one E and AE also. So it's kind of forming a closed group. So this is called closed group of nodes. And since here if you'll see that A, B, C, they are not connected to E, F, G, H. So similarly you understood the gist of that. So this is this is a concept called node. The other concept is resource. What resource is, you can assume it kind of an asset. So let's suppose even if you have a file and you want to share that file among so many things, so that will be your resource of some kind of information. Even another service can act as a resource for use one service. So let's suppose one service is there and which is using let's suppose other service like any other service to access any information or to get some work done. So that will also be called as resource for your existing one service which is using, or even the other network, that can also be treated as a resource. And depends like it depends like whatever thing you are getting advantage from is basically a resource for that particular service or component or node, whatever you want to call it. The third terminology or concept is abstraction. So abstraction is you already know this from object oriented concepts also. The gist is same, that You have to hide the max things which are possible from users, like complexities, like how you are distributing the resources, like how you are replicating your system, and how your migration operations are being done. For example, I told that in YouTube, like encoding decoding is happening, but you guys don't really bother about like how it is happening. It is happening for you. The complexities are hidden. They are abstract kind of for that user. So this is called abstraction. There is something called middleware, as you can see on the screen. Like this is a logical layer on top of nodes. So let's suppose you have this node 1, node 2 until node n, and client wants to access the data, but client will not go to node 1, node 2, because they don't know like which node will serve the purpose. Like, so what there will be a logical layer here, you can see, which I am drawn, and this is called a middleware. So client application will request to that middleware, and middleware knows that where to place that request and how the synchronization and communication will be happening. And it manages all the communication, and it even manages the security service. Like if you want to authenticate and you want to gain the authorization or authentication into the system, all those things they handle. And even they handle the failures and other complexities as well. So this is this logical layer is called a middleware into the system. Next is concurrency, which we have already studied here in the uh, in characteristics, but here we'll see that how what concurrency exactly is with the help of diagram. So multiple operations happening parallelly is known as concurrency, or multi-threading, something like that you can say. So here if you'll see, this is node 1 and this is node 2, this is node 3 and node n. Okay, so node 1 is performing t1, okay, at this particular time interval, and here same node 3 is also performing t2 at the same time. Okay, task t1 t2 is a task. Okay, so these are performed on the same time, and node 1 is doing it independently, node 3 is doing it independently at the same time. So they are being done parallel. Similarly, node 2 and node n doing t5 and t4 at the same time, and again like node n is doing t6 at some time interval, and at that time node 1 is doing t7. So this is done on the same time instance with different nodes parallelly. So this is a concurrency kind of thing in distributed systems. Next concept is coordination and synchronization. So coordination is nothing but the collaboration between operations and events. What all operations are happening, like you are sending a request, then it is being processed, and then it is being saved, or then the response is being sent. All those should be I mean, all those operations and events should be smooth. There should be a coordination between the services you write, and similarly there should be a synchronization and ordering of events. The access what you are doing for resources, that should be controlled. Like it should not be that you can access resources as many as times you can. There will be network calls also involved into that. So all those synchronization and coordination has to be there in the distributed system to work smoothly. Then something is called like word like architectural model. As you know from the word, that architecture involves like, it is nothing but the design or architecture of that system, like how the servers are organized, where the services will be placed, which service will call to which service, how they will be communicating. So this is like creating a design for that. And the architectural modeling is really very important, because you cannot achieve smoother management and smooth management of complexities without having a design ready. So it like, so here you can see that it defines the overall structure of the system. Then there is something called global state. This is like every component will have its distributed state, but as a system to perform, it should have the global state. and that will be the combination of states of separate processes, and you can assume it like it is a global view of entire system. So that has to be there. So yeah, that's it in the concepts, and let's see that what was the motivation to use distributed systems. So first motivation was like the resource sharing, like distributed file systems, etc., distributed databases. These are all the resources which can be easily shared by different services. So if you are not making a distributed system and doing everything on one particular server node, and all the complexities will be increased in that. And really, if somebody else wants to access that, it's very difficult for that. So resource sharing is very easy in distributed systems. And second thing is like scalability is easy. So let's suppose your one node or one node needs more memory. So what you can do is like you can scale that particular node itself. Or if let's suppose you have a payment gateway, right, and you want that payment gateway to be very scalable, multiple requests they should handle, all those things. uh, it's very easy in this although the complexity will increase, but scalability will be very easy. So let's suppose you have 5 servers or nodes doing different tasks, okay, and one node needed more resources. So you can scale that only one node easily with less cost, and 4 nodes will work as it is. So that's how it is. And you can replicate, replicate as in you can put more servers also, like mesh of nodes for that particular thing, whatever is more important. So that's the motivation behind, one of the motivation. The second is replication. So let's suppose you have a distributed system, you have one database where you have some critical information which should not be lost. So either you can create a backup of it, and backup will take some time to restore, but you can replicate that on the same time. Like when the request comes right here, simultaneously you trigger one job that will write in the replicated database also. So it will be like more reliable also, which is there. And obviously these points are really related. Like once you'll have a replicated system, obviously the availability and reliability of that system will increase. Availability is nothing but your system is available, and if one server goes down, the other server is serving request. So that's how the availability means. Obviously they come at some cost, but it is a kind of trade-off. Like what do you want? So yeah, those are the things which are the motivation behind using distributed systems. And now let's come to discuss some types of distributed system. First type is like cluster computing, which you are talking like they are kind of centralized, and they have like high performance, and they really have a minimum downtime. You can call them as homogeneous systems. So but on the other hand, uh, like grid computing, which is like heterogeneous, and they are decentralized. They are not centralized to one node or one server. Kind of, they are decentralized and distributed to others. So and for these grid computing, a lot of computing power is also being required. So these are the two major types of distributed systems. So and that's it about like distributed systems in this particular video. And why we discussed this distributed systems in system design series, because you should be knowing like what exactly we are going to design. For example, if in the interview you are asked that design in Instagram, so you know that this is a kind of distributed system and have different components, different nodes, and how will you design and wire them together to work coherently. All those things you should be knowing. So that's it about this video. And if you want to follow me anywhere, you can follow Thriver Ashish is my Insta, and LinkedIn and Twitter, everywhere. uh, and I post mostly educational content like this. So let's see you all guys on like in next video. Thank you.